Right, good morning. So welcome to Calc 2. We're going to just hit chapter 7, at least the first parts of it today. And I'm just going to assume that maybe we need more practice integrating. So that's just pretty much where I'm going to start, because I know how online learning goes, and we could all use a little bit more practice in starting this up here. Okay. So let me finish my coffee. I've got a little notepad thing here. There we go. So when we are going to integrate, okay, we have a couple of different pieces here. We have, come on, there we go. That's good. Okay, so we have a couple of different rules that we have to remember. Okay, we have the power rule, and that's the typically you have x to the n. We want to integrate this thing, and that's going to be x to the n plus 1 over n plus 1 plus c. Now, it's important that it looks like, you know, everybody's on the top here. So if you ended up with, like, if you just have x cubed, that's not a big deal, or x to the 1/4. That's not a big deal. We just add 1 to it. Sometimes I'll put a little 4/4 here, that's 1. So that way we actually end up with x to the 5/4 divided by, what do we end up with? 5/4 plus c, and then you can fix it from here. But the integration I usually do is one step, and then deal with the next step of this mess here, okay? So we'll end up, you know, you guys remember how to do this, right? It's 5/4, or 4/5 rather. Notice these pieces cancel, so we actually end up with a 4/5 x to the 5/4 plus c, and that would be our answer here. One of the big mistakes I see people make is, you know, something like x, like 1/x cubed, and people just want to add 1 to this, right? So they put the x here, and they want to do something like 1/x to the 4/4, right? And then end up with like a 1/x to the 4th, and then we have a 4 out here, again, plus c. This is terrible. Okay, we're all going to, if we do this, you're going to be very unhappy about it. Okay, it has to be up in the top. Okay, it has to be in the numerator for this thing to work. So what we have to do is we have 1/x cubed, we have to turn it into x to the -3 dx. Okay, so you can't just go integrating stuff that's on the bottom of a fraction. You have to put it on the top. Okay, and this is a pretty big mistake that I see. If we add 1 to it, right, you're $3 in debt, we're going to pay back $1. Congratulations, now you're $2 in debt. Okay, plus c, so we end up with a negative, this negative. Okay, 1/, we can leave the 2 on the bottom, that's okay, but we'll change that negative exponent back to a positive 1 by flipping this to the bottom. Okay, and we'll end up with a plus c. Okay, and again, that's why, like, the integration step is one part, and then the next part is we go through and do something like this. Okay, so that's what we are. Okay, so this is a mistake I saw pretty regularly last time. So just be careful about the fact that it's there. Okay, so that was power rule. The other rule that you know happens to be, well, 2 other rules you know. X to the -1, right? If I want to integrate x to the -1, then if I add 1 to it, right, we're going to end up with x to the 0/0. Which is not something you want to do. Okay, anything like if you ever find yourself like, oh, it's you know, 5/0, like, you know you messed up. Okay, because this is not an expression we want to say. Say, well, what is it? Like, a lot of people decide, well, it could be 0. Like, let me show you why that's not going to work. So if I have like you know, like 10/2 is equal to 5, then multiply both sides by 2. We get 10 is equal to 5 times 2 is 10. And everybody's happy. We're good. However, if we do a 10/0, you say, well, that could be 0. If I multiply both sides, then we get 10 is equal to 0. Wait a minute, we don't want that. So that's it's an easy way to check And if you end up with something over 0, again, like you've made a horrible mistake at some point. Okay, question every decision in your life. Don't let this happen. Okay, if this happens, you see it like, oh, I knew I should have done. I should have used a different rule. So this is a different rule. So instead of x to the -1, right, that's just 1 over x dx, and you have a special rule for that, and that's the logarithm of the absolute value of x and then plus c. I know a lot of students hate the fact that it's in an absolute value. The reason that has to be, because here's the graph, right? Here's 1 over x, right? Looks something like that. Looks something like this. And we don't really know like what side it's going to be on. So if you're trying to integrate, say, from here to here, we don't want to put a negative number inside of a logarithm. It's undefined. We don't like that. So we're gonna put absolute values in there to remove the fact that that's going to be an issue. Okay, the graph for natural log absolute value of x. Okay, that's y equals ln absolute value of x. So here's 1. Okay, what the natural log function looks like is just like this. The absolute value, it just means that we have it on the other side too. Okay, so that's all it looks like. So hopefully seeing it gives you less reason to kind of be intimidated by it. Don't be intimidated by this. It just means that, you know, if we have a 1 over x and happens to be in the, you know, it happens to be in the 3rd quadrant, that we just have to deal with it. And this is a really easy way to deal with it. Okay, so there's that. And then the other kind of integral we have is e to the x. Okay, I know this is everybody's favorite function too. And this is the easiest integral somebody can ask you for, because integral of e to the x is just e to the x plus c. There's another rule that says, well, what if it's not just e to the x? What if it's something like e to like the 3x or something? And I hate the fact that our book puts it in a spot that's really, it's too close. They should have introduced u substitution first and then put this one. So I think they introduced this a little bit too soon. So what I often do is just say, well, especially if I'm new and I haven't done it in a while, let u is equal to 3x, du is equal to 3 dx, right? So what we're going to have to do is we're going to say this is e to the u, okay? And du is going to be 3 dx, but I don't have a 3 here. So what we're going to do is we're going to say this is 3 over 3, that's 1, dx. And I'm going to group this part here to be my du. And since we can, if it's multiplied, right, we could slide a constant through our integral sign. So this is going to be 1/3 integral e to the u du. And now this part kind of looks like what we started at the beginning, which is a nice easy integral now, pardon me, which is equal to 1/3. And then we have e to the u plus c. What the heck was u? We have 1/3 e to the 3x plus c. So if it's a little tricky, maybe you've got a fraction in there, you've got a decimal in there, you're a little unsure, you could do it in 2 steps. Nobody's going to know. Okay, you can get to the end and say, oh, that one was really tricky. You say, yes, I know, I'm brilliant. I did it. So I just did this off the top of my head. Okay, but only you know, and it's fine. Okay, I want to see you guys work it out if you need to work it out, but but that's okay. I'm not going to tell anybody. All right, so that's fine. So I think those are the rules that we have for the most part. Okay. The other big thing that I see students make a mistake with is if you have an f of g times a f of x, a g of x, and an f of x dx. Okay, this works. If you have f of x plus g of x, and everybody's got a dx on it, and you go ahead and say, well, I can integrate 1 and then the other one, that's fine. Everybody's nice and happy. But you cannot go through and say, well, what if I went through and said this is g of x times integral of f of x dx? Like, you can't do that. All right. So we have a special rule, just like when we took a derivative, right? We took the derivative d. We had f of x plus g of x, right? Like x squared plus x. Okay. We were fine saying that this was f prime plus g prime and going along our happy merry way. But if you remember, when we had this thing times g of x, we couldn't do this. We couldn't say this was f of x prime times g prime. We could not do this. The product rule we had to deal with. Okay. So if you remember, right, this was derivative of the first times the second, and they change places because we have the first times the derivative of the second, and that's how we had to put this together. It's the same thing with integrals. If they're multiplied, there's a different rule. You haven't learned it yet, but it's a different rule. Okay, so you either have to multiply them together by hand and then integrate, or you have to wait until chapter 8 where we do this. Okay, but just be careful about when you have them multiplied together. It's a very common mistake I see. So try to not make that mistake. Okay, so let's go through and kind of walk through some of our homework. Okay, and I'm pretty receptive. Like, I didn't understand how to do this, so could you show me another one, or could you do one where this didn't work? Okay, so you can send me questions here. You can send them via email. Okay, we try to just be good about answering questions like that. Okay, so this is not too bad as a beginning one, right? 10x plus 8 integral, just to warm us up. So this is a plus, so it's adding two functions together, so we can go ahead and say this is 10x dx plus integral of 8 dx. You wouldn't normally need to do this. I'm just being a little bit more formal about it because we just did it, and we just did the general sense. So what we're going to say is, okay, it's going to be x squared over 2, okay, plus 8. We technically have an x to the 0. If we add 1 to it, we're just going to get x to the 1 divided by 1. And then we technically could have a c1 for this integral plus a c2 for that integral. But these are two constants I'm adding together, right? Like 2 plus 5, okay? We're just going to have one constant at the end because 2 plus 5 is still a constant. We have e plus pi, whatever we want, okay? It's still going to be something like this. Okay. So 10 over 2, that's going to be 5x squared plus 8x, and then we have our c, and that's going to be our answer for this guy. Okay, so I guess we could do something like this, 5x squared, okay, plus, what do we have? We have 8x, and then plus, do they tell us? No, some books will tell you which constant they want you to use. Like some will use a, but whatever. So that'll be nice. All right. So let's see here. Good one. Okay. So we have integral of 6x to the 7/5 minus 7x to the 3/5. Okay, and again, this is one where, like, I don't know, because I don't deal with fractions very often, so adding 1 to this might be a little tricky. So when we go to do a fraction here, we have 6x, and we want 7 over 5 plus 1. 5 over 5 looks like 1. Divided by 7 plus 5 is 12/5. Okay, minus, now we have 7x to the 3 over 5 plus 5 over 5. That's going to be 8/5. Okay, So here we have 6x to the 12/5 divided by 12/5 minus 7x to the 8/5 divided by 8/5 plus c. Okay, that's automatically, so if you forget the c when it had to be there, that's automatically a -1. So since we grade out of 6 points, that's like automatically a one grade deduction here. So be careful. That's just how that works. Okay. And then what we're going to do is we're going to say, well, that's 5/12, right? And this is going to be 5/8. So we can cancel, right? 5/12. These will cancel. All right. So we have 5 times 5/12 times 6 x to the 12/5 minus, and then we have 5/8, right? 5/8 here. So they cancel, times 7x to the 8/5. See? And then we have to just clean this up. Okay, so 6/12, right? That's going to be 2. So we're going to end up with, we're going to, no, 5/2, x 12/5 minus, and in this one, there's, you just have a mess. There's nothing you can do with this. 35/8, sure, delightful. X to the 8/5 plus c, and that's what we're dealing with. Okay, so that one was a little tricky because of the fractions, but overall, still the same kind of question we just did. All right. So, let's go ahead and write this down. 5/2, 5/2, x to the, what are we dealing with here? 12/5. Okay, plus, what do we have here? We have 35/8. All right, x to the, okay, x to the 8/5. Okay. This guy, 8/5, and then plus c, otherwise it'll tell me I'm wrong. C, and that's the kind of thing you're looking for. Okay, and then we'll see. I did something wrong. Oh, I put the minus, I put plus. So fortunately, they didn't say, nope, you're all wrong, do it again. Thank goodness. All right. Let's do, all right, this is the first kind of thing we talked about, okay? That we have to put things in the numerator rather than the denominator, okay? So a couple of things you have to look at when you're taking this problem apart. So we have pi over x cubed plus, okay, e squared over square root of x. So if I asked you to put e to the x in your calculator and press equal sign, you're not going to get very much. You're just going to get like e to the x, and it's going to tell you that. Okay, so it doesn't have a numerical value because we don't know what the heck this is. Okay, I mean, if it's squared, that's one thing, but if it's -2, that's a different thing. So what we have to do here is we have to recognize that this piece and this piece, like these are just constants. They're trying to trick us here. We're not going to fall for it. Okay, so what we're going to have here is we're going to have our pi. The x is the thing we care about, right? That's the thing we have to worry about. So this is x to the -3 because we're going to bring it upstairs here. Plus e squared, we have x to the square root of x is like an algebra way to do it, but we're going to do calculus, so we're going to raise it to a negative exponent, rational exponent, and that's what we're going to be dealing with. Okay, and again, we don't even really see the pi. We're not even seeing the e squared because we know they're constants, so they're not going to really. They're just going to slide through the integral part. We don't care. Okay, what I mean that is technically we're doing this, right? We have a sum of two functions plus integral of e squared x to the -1/2 there's dx's, there's dx's. And when we go to actually do our calculus, technically this is what we're doing, is we're saying pi integral x to the negative 3 dx plus e squared integral x to the negative 1/2 dx. We're not going to write this out every time, but technically that's what we're doing. So when I say the constant slide through the integral, I don't mean like at the same time. I mean like we broke it up and we slid this one through the integral sign, and we break it up and we slide this one through the integral sign, because they're both constants. You cannot do this with an x. Okay, so be really careful about that. I see a lot of students do something like this where you have like x and x plus 1. They're like, well, I don't want to deal with this, so we're just going to x. You can't do that. Okay, you can't slide this x through an integral sign. It's not going to work. The integral sign is working on the x. You can't just like, well, just pass it through. I'm like, no, I can't do that. You got to multiply this out, right, and integrate x squared plus x, and we know how to do that. Okay, so just a long-winded explanation for this one. Okay, so that's pi, and then we have integral at 1, so that's x to the negative 2, negative 3 plus 1, divided by negative 2. Okay, and then, oh, we integrated, sorry. There we go, get rid of this. Okay, once we have integrated, we used up the sign and we used up the dx. They're kind of like a catalyst to like, we did the operation, the dx kind of helped, but we've done the operation, so it's over. We don't have to keep writing it. Okay, and here's e squared, add 1, so negative 1/2 plus 1, right? That's positive 1/2. You're in debt 50 cents, you give your creditor $1, right? And now you're plus 1/2. Okay, so this is x to the 1/2, we added, but we have to divide by half. And again, we have our two c's, but we just have c. All right, so this is going to be negative, right, because of this negative right here, pi over 2, okay, we put the constants out front, times 1 over, and we can put the x squared on the bottom. Okay, and part of what you're doing, part of what I'm doing, is I'm making this a little bit easier to read for myself. So I usually like to put the constants off in front, you know, somewhere other than the x, and we'll make this a positive exponent again. Okay, but if you wanted to say that this was negative pi over 2x squared, this is perfectly right. All right, so there's a lot of ways to display it. Do it in the way that makes you a little bit happier, ways that you can, you know, when you look at it, you're like, okay, I know what I did there. Okay, because, and I tell this to Calc 2 like every time, I'm sorry to be the bearer of bad news for you, but not a lot of people end up taking calculus. And in your office or wherever you end up working, you're probably going to, I know that you don't feel like you've ever been the math person in your friend group or anything like that, but I've got bad news for you. You are now the math person. Okay, and most of the stuff you're going to be answering is stuff like, does this work? Like, yes, this works. Okay, so you're going to, you know, if you have people doing stuff like this, this is where a lot of your help is going to be. You know, if people are asking you for how do I do this, this is going to be your, you know, this is going to be mostly what you end up dealing with. Okay, so being really good at being able to manipulate fractions, because most people are terrified of them, you're gonna, you know, that's what's going to help for you. Okay, being able to do a little bit of calculus, great, but you're going to be doing more of this to help people than a lot of other stuff. Okay, so. Oh, I'm not going to type that in. Let's see. Let's look at 8. Okay. Next issue. Okay. So remember, we talked about, so there's a couple of different ways we could do this. All right. I know this in section 7.1. I'm going to borrow from 7.2 when we do this. Okay, what you do not want to do, because there's a couple of ways you can go to kind of mess up. You do not want to write this like that, right, with the integral. I mean, you can, but your next step here is to multiply this out. What you cannot do, okay, so this is, again, this is going to make us very sad. If you try to do 9x plus 2 times integral 9x plus 2. Okay, you can't, this is not good. Okay, again, this will make all of us very sad. Okay, just 2 y's. Okay, don't do that. What I'm going to do is I'm going to borrow from 7.2. I know we haven't gotten there yet. What this section expects us to do is to multiply this out. Okay, so we have what? 81x plus, let's see, 18 times 2 is 36 plus 4. And they would want us to do this. And we could do that. That's fine. How would I say this? The astute student. That's what math books would usually say to intimidate you. Back when I was going through this stuff, I was never the astute student, by the way. They would say things like, let u equal 9x plus 2. All right. Now notice that's the thing inside of the squared. And du is just going to be the derivative here. So that's 9 dx. All right. By the way, even if you end up not using the substitution, or you're like, well, that works, but I found a better way. Every time you make a substitution in calculus, your next step should be what was the derivative of that substitution. Okay, almost all the time. So I don't know how many Looney Tunes you guys watched when you were little, but I mean, it's a thing. It's like it's reflexive that you would do, right? And the same thing with a u and a du. Okay, it's just be like you made a u, you made an a, you made whatever substitution you had, you automatically take the derivative of it, even if it turns out that you actually don't end up using it. In almost every case, you end up using the substitution. So you have to take the derivative of it. Okay. So let's go ahead and substitute out some things. So remember, we started off with 9x plus 2 squared dx. Okay. So what we're going to say is, well, u is equal to 9x plus 2. So we have integral of u squared. And notice what du is. Du is 9 dx. So here's our dx. I'm like, great, I need a 9. So let's put in a 9 and a 9. So we can pull this to a 9 dx. Okay. And then this 1/9 here is just going to come out. We're going to say this is 1/9 integral u squared. And this 9 dx here, 9 dx, is our du. Okay. So we go ahead and we say, okay, that's nice. So it's 1/9 out in front. We have a u cubed over 3 du. Okay. So this is going to be 9 times 3. That's 1 over 27. And then what the heck was u? U was 9x plus 2. Cubed plus c. Now you're going to get a slightly different answer if we went through and multiplied it out. Okay. So we can go ahead and do that. So we have integral of what? We have integral of, I did this, 81x squared. I mean, we could go ahead and just go ahead off to the side. I don't have anything to show. Okay. So 9x times 9x, that's 81x squared. We have 2 times 9, which is 18x. This 2 times 9, which is plus 18 times x, right? Plus 4, 18 and 18 is going to be, I think, 36. Okay. x plus 4 plus 81x cubed. Oh, sorry, x squared. Okay. So what are we going to have here? We're going to have x squared plus 36x plus 4. So we're going to have 81x cubed over 3, okay, plus 36x squared over 2 plus 4x plus c. Okay, that's what we're going to end up with. So we have 27, 81 over 3, x cubed, plus 18, x squared, plus, I'm sorry, x cubed. Oh, I messed up. That's not right. No, we're good. X squared. Okay, we're fine. And then we have just 4x plus c. I don't want to go through and multiply this out, so I'm going to, the other way the math books would kind of tease you would say, exercise left for the reader. Thanks. So what we could do is we could multiply this out, but it's a cubic, so best of luck. Okay, but so it's not best of luck. It's just going to be very tedious to multiply this out all the way out. So if we did multiply this out, okay, whatever we have here as a constant is going to be different from this constant. Okay, and that's okay. We're allowed to have different constants. They're just constants. Okay. So that's if you don't get quite the same thing here. Like if you end up with like a 8 over 27, and this one comes up with something a little different, that just means the c's are different. Okay, but that's it. All right, so let's see here. Actually, tell you what, I'll go back to that one. That's a good one. All right. Okay, for this one, okay, so we have square root of x plus 6 divided by 5 cube roots of x. That looks delightful, doesn't it? Okay, the issue with this one, okay, is that again, a lot of students they want to do this. They want to say, well, we have an f of x divided by g of x, right? This top part is the f, the bottom part is the g, and they want to do this. They want to say, well, we could integrate f of x divided by g of x, right? Or the integral of f of x divided by the square root of g of x. Okay, again, you do not, this is terribly wrong. Okay, so don't take this out of context. He said this. No, I did not. Okay, I gave you an example of something that was terrible. Okay, not an appropriate way to solve this. So this don't do this. What you want to do here is you want to say, well, this is integral of x to the 1/2 plus 6 divided by 5 x to the 1/3. Right? That's what the cube root means. And what we're going to do is we're going to say this is x to the 1/2 over 5x to the 1/3 plus 6 5x to the 1/3. Okay, you could divide up the tops of fractions, right? If we have 4 quarters, I could put 1 quarter in one pocket and then 3 quarters in a different pocket, and I still end up with $1, right? What I can't do is if we have 4 quarters and I say, well, I'd like 4 over 1 plus 4 over 3. Okay, this I can't go to the laundromat with $1. Well, I can't go to the laundromat with $1 and expect to get anything done anyway. But I certainly can't turn my 4 quarters into $4 plus 1 1/3. It doesn't work that way. So this is another one where like you can separate the tops, that's fine, but you cannot separate the bottoms like this. Okay, so all I did was I just separated the top. Okay, now I know that you've been taught that there's a rule for exponents when you're dividing them. You may not remember it, but what we're going to do is we're going to say this is x to the 1/2 and then minus 1/3. Okay, that's the rule for dividing by exponents, right? This is like a 1/5 here. We can push this to the side. So this is integral of 1/5. We have x to the 1/2 divided by x to the 1/3. So this is how we deal with it, right? We have 1/2 minus 1/3. Dealing with the fractions, right? We have 3/3, 2/2. So this is 3/6 minus, right, 2/6, which is just 1/6. So this is 5 integral x to the 1/6. Okay, dx. Okay, for the other one, there's not much we can do with it. So this is plus integral. We'll prove the 6/5, right, out in front, and we just have x to the negative 1/3. It's 1/6. And now we can just integrate them as we've done before. Okay, so it's not so bad now. But there is a little bit of processing we have to deal with before we get into all of this. Okay, hold on for a second. I'm going to pause something here. All right. So that's what we have here. Okay. Just make that have a sound or something. Okay, now we just have to add 1. So this is 5x 1/6 plus 1 is 7/6 divided by 7/6. Okay, plus 6/5. We have plus 1 here, right? Plus 3/3. So negative 1 plus 3 is 2/3 divided by 2/3. Okay, plus C. Now we just have to clean this up. Okay, so there's going to be 6/7. 6/7, just multiplying by 1. That all cancels. And then we have 3/2. This, so we have 6/7 times 5/1, x to the 7/6 plus, and here we have 6/5, right, times 3/2. That's all of this business. X to the 2/3 plus your c. Okay, and then we just have to deal with all of this. So with this fraction is 30/7, x to the 7/6 plus, and there we have, I guess we could do a little bit here with 6 divided by 2 is 3, so we have 9/5, okay, x to the 2/3, and again plus c, and that would be our deal here. Okay, so that's what we have. What I should have done was taken this whole week stuff to go through. All right, I messed up. All right, so tell you what, I'm going to go ahead and stop us here. Okay, so I'm going to stop recording. We'll go with this. I'll put other videos up for the other sections, and I'll be a little bit more cognizant about something else. Okay, so let's go ahead and stop recording.